So welcome all to my session, No More Breaking Changes. And first, let me introduce myself a little bit more. I'm Rohan Horstman. I am a data solution architect within VGZ. VGZ is a health insurance company within the Netherlands. Um, and well, in the past, I've always been working within the Microsoft BI space, SSAS, SSIS, SSRS. Well, probably you are familiar with it as well. But in the last couple of years, mainly focusing on the Azure stack, and also within VGZ, we are well, working on building a data platform within Azure. Um, and when I'm not working, I love to cycle, as you can see on the right side. That's me cycling up a mountain in France with a little bit better weather than it is right now here in the Netherlands. Um, yeah, so that's me. And today I want to talk about breaking changes. Um, so let me first start off with what is the problem that we are going to tackle, what I would like to tackle. Let's first start off with a architecture for a data platform. Uh, so this is the architecture that we have within VGZ, or what we're trying to achieve within VGZ at least. And you are probably familiar with it because this is the reference architecture, also a little bit from Microsoft. And on the left side, you can see all the sources. We can then use data integration pipelines within Azure Synapse Analytics or within ADF. That doesn't really matter, but in our case, we use Synapse Analytics pipelines, and then we store the data within storage accounts within Azure. Sometimes we use Delta Lake capabilities to have a little bit to get an actual set from all the deltas that we loaded. And on top of that, we have dedicated and a serverless SQL pool to enable our users to query the data or to use Power BI to build reports on top of that. And well, to enable all these things to work together, we orchestrate everything within a metadata database, which you can see over here. And that one is actually pretty important because we store the metadata from our sources in there, but also we log all the pipeline runs in there so that we can track performance, or that we can see issues that are um, that are there within the pipelines. And well, main thing I want to take out of here is that this is heavily connected, and that we have a lot of dependencies within our platform between those all those components. So if we look into a solution where we would say, well, we are sourcing data from a Oracle database and we store it in multiple layers within storage accounts, for instance, the raw layer, the cleanse layer, and then maybe a data mart layer, and then eventually you would enable users by letting them query it via a dedicated or serverless SQL pool. If you want to do that whole process, well, we actually need to make use of a lot of components. Well, I just said that we are using Synapse, but you could also use the Data Factory for the orchestration. And well, within Data Factory or Synapse, you would need link services to connect to the data source. You would need a data set, because the data set is about telling you how the data looks like, and actually a pipeline which runs certain things on top of that data set and link service, and to actually copy data from A to B. And as I said, I would like to log everything that I do within the metadata database. So, we are using stored procedures to start the logging and stop the logging, and the outcome of those stored procedures will be stored in tables. And eventually, we would need a SQL pool where we create tables or even a view where we can have a dimensional model, for instance, that the users can query. So looking back, we are sourcing data from Oracle to eventually a data mart. We actually need to use all of these components. And well, we are working CI/CD, and the way we work is that we create a from the main branch we create a feature branch. Within that feature branch, we start developing, and eventually, when we think that the development is finished, we ask a colleague of ours, well, can you review our work? And if he or she agrees, we create a pull request, and it will be agreed, and we release our software. And then we will release it from development to test, and from the test environment to the acceptance environment, and from the acceptance to the production environment. So just a normal DTAP street approach. But when, in the case of a breaking change, you can actually develop something and test it, unit test it in your test environment. Then you run an isolated run within your acceptance environment. And then eventually, when you run it on production and you didn't took knowledge of the fact that certain components are also used in another pipeline, for instance, then you could actually introduce a breaking change. So it would be very good if you know upfront where your software is used, and if you have components that are reused in another component or another pipeline, that you are that you know that upfront instead of afterwards, and so you can prevent to create a breaking change. So that's actually the problem that we would like to tackle. To get better insights up front instead of afterwards. Because if it's already in production, well, you don't want production to break. So I'd like to give you a demo, because I have my own mini data platform created. And well, as I already said, I like the cycle, and all my rides are actually logged within. I ride with a bike computer, a Garmin, and that stores all my bike rides. And as you can see on the right side, that's a bike ride I did within my vacation this year. And what I did, I sourced all my data from Garmin Connect. That's actually where the data is stored, to a landing zone. And from that landing zone, it's going into a cleanse layer. And from the cleanse layer, it goes directly to a SQL database where the users, myself, can actually query the data and gather insights from that. So let me switch to my demo environment. So here it is. Like I said, my demo environment is not within Synapse, but I built it in Azure Data Factory. But actually, it looks quite the same. So what I did, actually the process that I just showed you, that's what I did. Over here we have a scheduling pipeline, and I will trigger it directly so that I can show you guys that this is actually working. And first it will, I get all the files zipped from Garmin, so it will unzip the files with this pipeline. Next up, I will cleanse that data. So those are all JSON files, and I would like to have it in Parquet. So this copy data task actually unzips, copies the data from a JSON file format to a Parquet file format, and then eventually it will actually copy all the data from a Parquet format to the data mart in the SQL database that I created. And before this load is started, it will get the database load details from the metadata database, so that I actually load the last loaded data from that layer and not all the data. And what you can also see in between, I will start I have two stored procedures over here that I will execute. it's actually the same stored procedure, but with different parameters. And over here, I will start the logging. Over here, I will end the logging. And well, if this one is finished, I can show you within my metadata database that it will actually log some records over here. So let me show it just there. Oh, sorry for that. Let me just show it over here. And as you can see, we are running it at the moment. It's this run that I just started. Zoom in. This is the run that I just started, and well, it's still running. Probably it's not anymore. Well, it still is, but because I already I thought that this could be happening, that it's taking a little bit longer. I also started the run 1 hour earlier already, and this is actually the outcome. So what it does, it's logging a start run, start date time, and when it's ended, it's logging a end date time. I can see the data read in well, MBs, that's not actually correct, it's bytes. The rows read and the rows written. Well, in case it's a target container, because that's only when it's in the Delta Lake, it will also log the container and the target data lake directory, as well as the insert date time and the status if it is succeeded or in this case still running. But what we can also see over here, it's that it's not logging the row skipped actually. And that's something that we do want to have. Well, I can. Well, and now we can see that the first layer is actually loaded already, and well, it has still the same outcome. So that's that's looking good. But like I said, this one is not logging any skip rows, and we do want to also log that because when you look into this copy data set, over here I said fault tolerance is skip incompatible rows. So that means that we should skip those. But I do want to know when rows are skipped so that I can look into the data and see if there's anything going wrong or something, and I want to investigate. So what's the case over here? Luckily, I already know what the problem is. So the column is actually there, but the store procedure, if we look in the original store procedure, we can see over here that there's a rows read, rows written, but there's no row skipped parameter, and it's also not used in the query next to it. So, but I already created the change, and over here we can see that we do have that parameter, and it is used within the query next. So I will execute this one. Well, if this one is stopped, because otherwise we will get an error. Well, this is also correctly run. So I can now change the stock procedure. And in the meantime, I can also go back here and show you that the logging actually succeeded. If we're all good, yeah. So this one has also succeeded. So this one, the first row was actually sourcing the data from the landing zone to the cleansed layer. And over here we are going from a cleansed layer to the data mart. So I just changed the stored procedure, and the stored procedure is actually used over here and over here. But what we also need to do is to add the parameter over here, because otherwise this doesn't do anything with that parameter, and actually the pipeline will fail. Luckily, also that was something I prepared, so I have created a feature branch, like I said. And within this feature branch, I added already the parameter. As you can see, the row skip is over here, and we put a nil value in there. And over here, when we are finished, again we do the same thing, and but then we actually fill it with the row skipped property from the copy data activity. So let's debug this one. and check if everything is going correctly. So we start with the logging, and well, if all goes well, we should see a new row over here. Yeah, we do. So that's still working, and well, the copy data is in progress, and this is always taking a little while, but I hope that it is not taking too long today. Sometimes we will get some issues within Azure Data Factory with that, but I see that it's not queued anymore, but already in progress. So when it is finished, we should see over here the row script property also set. And normally this is going faster, of course. Well, I will get there back in a minute then. Well, let's say that this is going correctly, and I will just show you that it is. Then, normally spoken, we would create a pull request, or well, I ask a colleague to and show him that this is going correctly. Oh, well, there we are. And if I now do this, I can actually see over here the property row skip is actually 0, as you can see. So it's properly filled, and that's exactly what we wanted to achieve. So that's looking good. So normally spoken, then I would ask a colleague, well, hey, look, this is my change. This is what I changed, and can you approve it so that we can finalize the pull request and then bring it to production. For now, I don't, because this is only my own environment and I don't have a whole DTAP tree. But and when we are in production, you would just daily run the schedule pipeline, for instance. And I will start this one because that is actually where the breaking change is now. Because what will happen is, well, the first 3 are going fine. But this one will fill. And normally I would say, ask the audience if somebody knows why. But that's a little bit difficult now. But if we look into this pipeline, because that's actually this pipeline, the lookup, we didn't change that one, but over here we have the store procedure, and over here we also have store procedure. And it's actually the same store procedure that we edited right here. But over here we didn't, over here within the data mart layer, we did not edit the setting. So over here we don't have the row skip. And as you can see over here, it's also not there. So this one will fill eventually, if we are that far. And that's actually the breaking change that we just introduced now. Well, this is a very small solution, and you would probably know that when you change it over here, you should also change it over there. But if you have a lot more pipelines over here, for instance, well, you work within a company where you have, well, I don't know, maybe hundreds of pipelines that are all using the same store procedure, then you would like to know upfront which store procedure is used, so that you can actually, that you know in which pipelines you should do a adjustment. And that also the person who is doing the review on the pull request can see, well, here we expect a change, and that he or she can also check that. So, well, here again, well, translator was a little bit faster than last time, unfortunately. Oh well, it was fortunate because it's also nice. And over here we can see that we actually have the cleanse layer again. That one logged everything well. Oh, that's what that one is finished then. And then we don't see anything else, and that's actually correct because probably this one is filled now. Yeah. And well, if we look into that error, the message is store procedure or function as be metalog extract run expects parameter row skip, which was not supplied. Well, that's indeed correct. We did not supply that one. So yeah, and if you would have deployed this one to the production environment, and then the next day you would come into the office and look into it, then you see that something is failed, and then you need to create a quick fix to make sure that not all pipelines are failing. And if you have the business relying on it on the products that you are building, yeah, well then you can run into yeah, into problems, and that's something that you don't want. So that was the first demo. So let's get back to the presentation. So what we just saw is actually, well, over here on the bottom you can see the pipeline that we have, and well we have the start load store procedure that we use, the stop load store procedure that we use. We have a copy data activity, and well, if we can see over here, which are all the dependencies, we have a pipeline. The pipeline has activities, those three. Those activities, or they run on a linked service. Those are the store procedure activities. Or they have a data set, which is the copy data activity, and they also use a linked service. So there we already have a lot of dependencies. And then we also have dependencies with the metadata database, because over there we have a store procedure that we are leveraging to log all the data that we have right here and here. And we actually log the data into a table. So it would be nice, like I said before, that we know upfront where is the store procedure used, for instance, or where is that linked service used, so that we can test it properly. So how can we manage with that? I looked well at VGZ. We had the same problem. We also had a breaking change which we brought into production, and well, then we thought, well, how can we manage this? And well, we already know that everything that we do within Azure Synapse is actually code. Only we build it via a GUI, but actually it creates JSON files, and I will show you in a minute. So we thought, well, then it should also be possible to interact with the JSON and to get all the dependencies out of there. But before we were going to build that one, we looked into what is available in the market, and actually, if you I have the solution link within the presentation over here, so you can see it over there if you also want to make use of it. But what this does, it's from SQL Player, and it's actually a PowerShell library, and it goes through all the JSON files, creates well, artifacts, let's say, and it shows ultimately it creates a mermaid diagram, yeah, where you can see all the dependencies. But yeah, we couldn't make use of that in the way that we would wanted it to do. So what we did, we let it generate SQL. And also, it's only showing the dependencies within Data Factory or within Synapse, but we also wanted to know which actual store procedures are used because of the problem that I just showed you. So we we added some changes to get insights in the used store procedures and get the output in SQL so that it can be queried. So there is the second demo. I will switch back to my desktop. So we are back within Azure Data Factory. We are still in my change branch, and well, as I said, everything that we see over here is graphic, but actually behind it we see we have the JSON. And if we go back to, for instance, the cleansed pipeline, and we open the JSON over here, then we can actually see all the dependencies that we have. Let me do a quick search. So, for instance, the source is actually reference. Refer. Well, I cannot find it now, of course. What we can see over here is actually the data set that we use, but also the stored procedure that we are using. Oh, that's over here. And if we know upfront where the stored procedure is used from the JSON files, yeah, then we know where we should do all our adjustments. So, like I said, we have this linked to, or I didn't say that yet, but I linked it to a Git, and all these JSONs are actually stored in the Git repository, which I have over here. So if I click on pipelines, then I will actually see the pipeline over here. So here we have the same pipeline that I just showed you. And for the solution, what is needed is that it gets the whole solution. So actually what we see over here to your local computer. So within my PC, I have on this in this folder, I actually have well, my repo, as you can see. So all the JSONs are stored over here, and yeah, so they are stored over there. And what we can now do is actually use the module. So first I will go back to the C drive, because then I know where to find my actual output file. Then the second step is to import the module, which is in this case azure.datafactory.tools. And I already installed it. And then I did my changes over there, and now I only need to import it from my local libraries. Then I set the root folder, and the root folder parameter is actually, well, this is the location that I just showed you over here, where the data factory is stored locally. And then the next step is to actually start start the tool doing its magic. And so we have the parameter ADF, and that will actually use the function import ADF from folder with the folder root folder, which we set in the previous line of code. And we can give the factory a name. In this case, I called it ADF main. And then I hit the enter button, and what it actually does, it's loading all the objects into this ADF parameter. And as we can see, we have 4 linked services, 4 pipelines, and 4 data sets, and that should also reflect over here. If we go to the linked services, yeah, indeed, I have 4 linked services, and if we look over here, I have 4 pipelines created and 6 data sets. So that looks good, and we actually have 1 factory. Yeah, that's also correctly, of course. And then the last step. Oh, sorry. The last step is to actually get an output file. Well, what I did normally, it's create a mermaid diagram, which you can easily put on your DevOps wiki page if you want to. But yeah, we wanted to do it in SQL so that we could actually query it. So I edited the get ADF doc diagram function to output a file in SQL, which I specified over here. So on the C drive, I would get a file named dependencies.sql. So, and that's how easy it goes already. And if I now go back to the Explorer, to the C drive, I would actually get the dependencies.sql. And In this case, what I did is I put everything into a temporary table, as you can see. That's the hashtag which is there, and it has a source and a target. So let me show you what is created. Hashtag dependency. So what we can see over here is actually, well, we have a source and this source makes use of this target. So this pipeline is making use of a certain link service. It's making use of a certain data set. Here we have some data sets which are making use of these link services. So over here, it's you can query the dependencies, yeah, like however you want to query it. And but what we had in the problem over here, which we had, was actually the stop procedure. That's this one. So I can actually query on this name. Copy it. I don't think it's with a like this. Well, actually, I know it is not like this because these should be removed. But I can already see it over here. This is the how I named it within the tool. So yeah, you could actually query on this only. But what you would like to have is to have this stored a little bit better, and that you could actually see a stored procedure name, a stored procedure schema, etc. Yeah, I didn't come that far yet. Well, and if I query it like this, I can actually see where the stored procedure is being used. And now I have the insight that I didn't only need to change the pipeline PL plans Garmin, but that I also needed to change the pipeline data mart Garmin. And that's what we actually forgot, and that's the reason why we now have a break and change. And I think this tool could be come in very handy if you have a very big environment that you need to manage. Yeah, so going back, that was already the second demo, and that's actually also wraps it up a little bit. I think the key takeaways are that I think that you should be aware of your dependencies, especially when you have a very big environment. I think it's great if you try to automate the discovery of dependencies so that it makes it way more easy to spot the dependencies and to also take action when needed. And yeah, like you just saw, make use of generic code as much as possible, because if you, for instance, within those logging components, make use of your own SQL queries instead of stored procedures, then you even have way more work to do. If you, for instance, change the table or those kind of things. So yeah, that wraps it up actually, and yeah, thank you very much. A little bit shorter than expected, actually, but I hope you all enjoyed it. And well, if you got any questions, well, we have some time left now, or otherwise you can hook me up via LinkedIn. And the link to my LinkedIn is also in the presentation. So thank you very much.
Thank you, Rohan. Actually, we have one hand raised by Cohen. So Cohen, if you want, you can unmute yourself and ask your question.
No, it was just a stupid me. I wanted to give the applause.
Okay, okay.
Okay. I'm so old. All these things, they look just the same to me. Right, and now I'm giving applause.
Thank you.
Thank you. Right, I think I just want to stress the fact that the code that Rohan has shown is available for download as well.
Yeah. If you within the presentation, I have a link to a SQL player. There you can actually just download it. And if you would like to have also my adjustments, then just send me a message via LinkedIn, and I will share it with you.